Good morning. This is Dr. Yogesh Agrawal, Associate Professor, Sagar Institute of Research and Technology, Bhopal. Today I will discuss the topic phase change cycle, which is used in the thermal power plant. Before going on the main slide, today I will discuss about the outline, introduction of the thermal power plant, equipment which are using in the thermal power plant, power cycles, law of thermodynamics, thermodynamic processes, Carnot cycle, Rankine terminology, thermal efficiency of the Rankine cycle. This is the content or the outline of the today lecture. This is the first slide of the today lecture, thermal power plant. It is a plant where the prime mover, it is a steam driven type of the accessories or the devices were used for the converting of the one form of the energy to the another form. Where water is heated, turns into the steam and it spins in the steam turbine which drives in the electric generator. After it passes through the turbine, the steam is condensed in a condenser and the recycled to the where it is heated. Thermal power plant working with basically using of the chemical energy of the fluid, and this chemical energy converted into the mechanical energy form, and this mechanical energy which is converted into the electrical form through the generator. So this is the main function of the thermal power plant, where the energy conversion rate, it is the going very fast rate, and the greatest variation in the design of the thermal power station, which is due to the different fuel sources such as the uh, solid fuel and the liquid fuels. Some thermal power plant also deliver the heat energy for the industrial purpose, for the district heating, or for the desalination of the water, which is the as well as delivering of the electric power. This is the main fundamental of the thermal power plant. There are the four type of the devices which were used. This is the boiler, this is the turbine, this is the condenser, and this is the heat pump. Boiler where the steam is generated, and the turbine, it is use of the steam which are generated by the boiler, superheated steam, and this is the expanded in the turbine section. After the expansion in the turbine section, steam will go into the condenser section where it will be condensed into the low pressure manner, and after that when the steam it is condensed into the liquid form, steam will pass through the pump where it will be recycled to the boiler is again. These are the equipment we are used in the thermal power plant. First is the cooling tower, which are the regenerated is here. This is the cooling water pump. This is the represented is here. This is the another unit, transformer, generator, which are the describing is here. 6 number is that is called a low pressure turbine. This is the high pressure turbine. Boiler feed pump, which are we are using in the 7th number. This is the boiler feed pump. 14 number, that is the coal conveyor, where the coal is supplying for the heating of the water and the combustion of the fuel. It is taking place, and after the combustion, the fuel, it is carried out in the S form. It is collected at the bottom side. The accessories which are we are used in the number of the parameters which are the describing is here. Economizer, it is the 23 number. Air preheater, 24 number. That is the air precipitator. This is the reducing of the sediments sizes. This is the precipitator. And reduced draught fan, which are using at the bottom of the chimney. 27 number, that is the chimney stacks. Another devices which are the using boiler drum as hopper. High pressure turbine already discussed. Feed heater, which are the already discussed. 19 number, that is the superheater device, which are the superheat of the steam after using of the steam, which are the supply from the boiler sides. Boiler drum, this is the 70 number, which are the using for the carrying of the water and absorbing of the heat from the fuel, and the converting of the water into the steam form. These are the power cycle which we are used in the thermal power plant. Carnot cycle, Rankine cycle, diesel cycle, Otto cycle, Breton cycle, Stirling cycle, and the combined cycle. These are the law of the thermodynamics: zeroth law, first law, second law, and the third law. Zeroth law, and the two bodies are in the thermal equilibrium, and second and third body also thermal equilibrium. Then first and third body is also thermal equilibrium because of the it is in contact with the each other. First law of thermodynamics: all the heat energy converted into the work done or the heat supply in the system, which are equal to the change of the internal energy plus of the work done. Second law of thermodynamics, it is the differentiate between of the first law, because of the there are the irreversible processes are the taking place because of the not any machine which are the converting of the total heat energy into the work done. Some part of the heat energy which is going into the rejection body or the sink body. The third law of thermodynamics concerns the entropy of a perfect crystal, which are the at absolute zero temperature, and imply that it is impossible to cool a system to exactly absolute zero. What are the thermodynamic process? That is the isobaric process, also called as the constant pressure process, isothermal process. It is also called constant temperature process, adiabatic process, isentropic process, isochoric process, and the throttling process, which are the using in the thermal power plant. Carnot cycle, which are the simplest cycle, number of the process which we are the use 1, 2, 3, 4. 1 to 2, this is the one process. 2 to 3, these are the one process. 3 to 4, this is another process. 4 to 1 is another process. So 1, 2, 3, 4, 1, these are the cycle. This is called a Carnot cycle, which is the not a practical cycle. This is the hypothetical cycle because of the no one cycle having of the 100% of the thermal efficiency. So 1 to 2, that is the isothermal heat addition in a boiler. 2 to 3, that is the isentropic expansion in a turbine. And 3 to 4, that is the isothermal heat reaction or the condenser, where the condenser it is taking place in the condenser device. 4 to 1, that is called isentropic compression in the compressor. The Carnot cycle efficiency, the process involved in the heat engine must be reversible and involve the no change in the entropy. This means that the Carnot cycle is the idealization, which cannot be possible in the practical condition. Carnot cycle efficiency, heat addition and the heat reaction, heat supply, which are the which is done at the boiler side, that is the heat supply. It is represented by the formula QH is equal to the TH S2 minus of S1, and the heat reaction which are the taking place in the condenser side, where it is done at a low manner. The efficiency of the Carnot cycle, which are the thermal efficiency, which are the represented by the eta, it is defined to be the work output upon the heat input. Work output, that is the QH minus of the QC, that is upon the QH, and the W upon the QH, that is called the net work done upon the heat input, is equal to the 1 minus of the TC by the TH, where the TC is the condenser temperature or the cooling temperature. TH is the hot body temperature, where the heat is supplying is the taking place. Where W is also called the work done by the system, energy existing in the system as a work. QH is the heat input into the system. TC is the absolute temperature of the cold reservoir. Carnot cycle feasibility. Carnot in theorem, no engine operating between the two thermal or heat reservoir can be more efficient than the Carnot engine operating between the those same reservoir. That is Carnot theorem. The Carnot cycle is the most efficient cycle operating between the two specified temperature limit, but it is not a suitable model for a power cycle because of the process 1 to 2 limiting the heat transfer process. Process 2 to 3, that is the turbine cannot handle the steam with a high moisture content. And the process 4 to 1, it is not practical to design a compressor that handle the two phases. This is the Carnot cycle feasibilities. Rankine terminology. The Rankine cycle most closely describes the process by which the steam operated heat engine, that is the most commonly found in the power generation plant to generate a power, and the over difficulties which are the occurring in the Carnot cycle, it can be overcome by the Rankine cycle, where the condensation it is the completely into the liquid form. It is represented by the 4 to 1 process, and 1 to 2, that is the as usual work which are the done in the Carnot cycle. This is the pump work. So there are also 4 units: boiler, turbine, condenser, and the pump. But it is the difference there. The condenser condense the steam expansion which are the done in the turbine. After the expansion, steam will go into that condenser unit. This is the condenser unit condense of the steam into the liquid form and convertedly totally into the liquid form, and there is a no moisture or there is a no steam particle which is the present in the condensing units. So that's why at the end of the condensation process, we will getting of the liquid form of the steam. That is the Rankine technology. Rankine curve, which are the represented in the TS diagram. Here are the 3 conditions. 3 is the wet condition, 3 dries, and the 3 is the dry saturated condition, 3 double dash, that is a superheated condition. Depending on the type of the how much amount of the heat will be added. So that's why the steam condition will be different. 3 days, that is the wet steam, where the amount of the heat supplied, it is the very less comparison to the dry and the superheated. So that's why the expansion it is done at the 3 dash to the 4 dash instead of the 3 to 4. If the steam is dry, saturated, that is steam expansion, it is done in the turbine, that is a 3 to 4 process. If the steam is superheated, it is called a 3 double dash. It is a superheater device, and the expansion it is the 3 double dash to the 4 double dash. So that's why here the diagram 2 dash, 3 dash, and after that 4 days and the 1 days, if the expansion it is not complete, or it is a having of the wetness, that is the Rankine cycle is a small rectangle. But if the expansion it is done at a closely of the less wetness, then the diagram will be the closely of the this circuit diagram, that is the condensation it is also done at the 1 process 4 to 1 process. And this is the cycle when the wet steam is taking up the 1 dash to 2 dash to 3 dash to 4 dash to 1. That is for the when the steam is having the wetness, and when the dry steam having the wetness is very less, that is the 1 to 2 dash, that is the 3, 4, and 1. This is the repeating of the cycle. The process 1 to 2, that is the working fluid is the pump from the low to high pressure. 2 to 3, that is a high pressure liquid enter into the boiler where it is heated at a constant pressure by an external heat source to become a dry saturated vapor. 3 to 4, that is called a dry saturated vapor expanded through a turbine generating the power. This decreases the temperature and the pressure of the vapor. And the process 4 to 1, that is a wet vapor, then enter into the condenser where it is condensed at a constant temperature. These are the curve, PV curve and the HS curve, where the 3 condition of the steam are the describing is here also. 3 dash to 4 dash expansion in the turbine when the steam is having the wetness. 3 to 4 when the steam condition is the dry saturated. 3 double dash to 4 double dash when the steam is superheated condition. These are the PV diagram which are the describing here. Constant pressure heat addition it is done is here. Constant pressure heat reaction it is done in the condenser section. Similarly, in the HS diagram, it is represented as here. So that's why the more heat is added, if the superheated steam is formation take place in the boiler condition. So that's why the here the area it is increasing because of the superheated steam is using in the turbine or the thermal power station. Thermal efficiency of the Rankine cycle, that is the heat input. It is a Q2 to 3. It is done at the heat input in the boiler section S3 minus of H2. Heat reacted, that is a Q4 to 1. It is done at the condenser section H4 minus of H1. Work output, that is the done turbine section W3 to 4 S3 minus of H4. And work done by the pump which are done. It is the pump section W1 to 2, the H2 minus of H1. Then the efficiency is equal to work output minus of the pump work upon the heat input is equal to the W3 to 4 minus of W1 to 2 upon the Q2 to 3. The Rankine cycle has a lower efficiency compared to the corresponding Carnot cycle 2 double dash 3 4 dash to 1 double dash with the same maximum and the minimum work temperature. But Carnot cycle having the drawback because of the it is a hypothetical cycle. Reason for the considering the Rankine cycle as an ideal cycle for the steam power plant, because it is very difficult to build a pump that will handle a mixture of the liquid and the vapor at a state of the 1 dash. This is the another reason. In the Rankine cycle, the vapor may be the superheated at a constant pressure from the 3 to 3 dash without a difficulty. In a Carnot cycle using the superheated steam, the superheating will have to be done at a constant temperature along the path of the 3 to 5. During this process, the pressure has to be dropped. This means that the heat is transferred to the vapor as it undergoes expansion during the work. This is the difficult to achieve to practice. This is the main reason for the considering of the Rankine cycle as an ideal cycle. So this is the today lecture. Thank you.